We interpret curly programs by running it in an interpreter that we've implemented in Plait. And our interpreter relies on various Plait constructs. It relies on numbers with addition and multiplication operation. It relies on symbols so that we can do symbol comparisons in the environment if we want. It relies on function calls and continuations where we can call interp recursively and the recursive calls can come back with a value and continue properly. But that Plait program has to ultimately run on some piece of hardware. And this piece of hardware knows nothing about lambdas and recursive calls and continuations and symbols and so on. Once again, this is an area that we want to try taking control of for a while. What we're going to do now is not compile our curly programs directly to the machine code, which, although we could do that, we're going to take a step that is similarly enlightening, which is that we're going to change our Plait program one that doesn't rely on various features that the Plait program, that the Plait language gives us. That is, we're going to make sure that everything that our interpreter works with is just a number. We're going to get rid of define type or type case, not have Plait's fancy pattern matching features and structure management features, but instead work in terms of just numbers. We're not going to rely on Plait's continuations. Instead, we will take control ourselves, as we know how to do, and make continuations explicit in our interpreter. And even then, when we took control, we still relied on Plait's ability to allocate continuation records. But we're going to move away from that. We're going to take care of allocation ourselves as well, so that we really get down to the same level of abstraction that the machine would give us. Even though we'll write Plait code, it'll look more like machine code by the time we're done.